Alright, now from here, implementing what we've learned so far, and implementing what we've learned so far, how the limit works. We already know how the limit works, right? So basically, we are just implementing the limit wherever I need it. So the first one, I'll be performing line integral for that question. So applying line integral, I believe you already know what it means, right? I said this is the formula for line integral. So the line integral, meaning I'm going to implement line integral to this first curve, and I'm going to implement what line integral to this what second curve. Now say this line integral, which is this this line integral is equals to the first curve 0 to 1 of p dx plus q dy plus 0 to 1 of p dx plus q dy, right? Now this curve is for what curve is this? What curve will you implement this limit? Check. Is it the first curve or the second curve? I'm implementing it for the first curve, meaning when y is equals to s squared. When y is equals to s squared. Then the second one, I'm implementing it for when y is equals to what? Square root of x. Now from here, I didn't know the function, just like the way we've done previously. I didn't know the function of y, I know the function of y, and to get my derivatives present in the line integral formula, just differentiate whatever function that has been given. Now for the first one, let's solve this first one. I have integral 0 to 1 all into bracket p dx plus q dy. Implementing using the curve y equals to x squared. I said previously for the last video, when you are applying line integral for each curve, you make all the terms, you express all the terms as what x. You express all the terms as function of what x. You express all the terms as function of what x. So what that means is that I'm expressing, in this case, my unknowns are what? P, dx, q, and what? dy. So meaning I'm expressing p, dx, q, and dy as a function of x. Everything must be expressed in function of x. By the time you express all in function of x, you are going to integrate, then substitute this limit. Similarly for this second curve. Alright, let's see how it works. For this first curve, I'm having that y is equals to what? S squared. But before that, what are the vector field, meaning p and q? Given from the question, p is given to be what? The vector field p is given to be 3x squared minus 8y squared. And q, the second vector field, is given as 4y minus 6xy, right? Now, meaning that p and q, p or q must be expressed as a function of x. Q or q must be expressed as a function of x. Now, I'm giving that y is equals to x squared. So anywhere I see y equals to x squared, anywhere I see y, I'm going to substitute x squared, right? Now, from here, observe. I'm having y squared. If y is equals to x squared, meaning y squared will be what? Y squared will be what? X raised to the power of 4. X raised to the power of 4. What we did is that take square to both sides. X squared over square. So by the time you multiply this, you have what? X raised to the power of 4. So if y is x squared, y squared is also what? X raised to the power of 4. Now, substituting the necessary terms, I have that integral 1 to 0, what my p, vector field, the 3 square minus 8y square dy, okay, dx plus all into brackets, what's my q? 4y minus 6xy all into brackets dy. But in this case, since I said I'm expressing all functions in terms of x, meaning I'm differentiating with respect to what? X. So meaning this dy has to be written as what? Dx. So we are already giving y to be x squared. We are already giving that y is equals to x squared. So differentiate this. By the time you differentiate this, you have that dy over dx is equals to what? 2x. Dy over dx is equals to what? 2x. Cross multiply. This becomes dy is equals to what? 2x dx. That is, in place of this dy, you substitute this. In place of this dy, you substitute this. Alright, meaning that I have integral 0 to 1 all into bracket. I'm substituting dy as 2x dx, meaning my new integral function becomes 3x squared becomes what? 3x squared minus 8. Now I'm seeing y squared, and y squared here is what? X raised to power 4. Substitute, multiply by x raised to power 4 dx plus 4 all into bracket. I'm seeing what? What's y here? X squared multiply by x squared minus 6x. I'm seeing y again. Substitute dot x squared. Then multiply by dy. I believe you know how we got this dy. We differentiated this. So meaning I'm substituting this. Meaning I'm substituting 2x dx. Alright. Do your necessary expansion. Meaning integral 0 to 1 all into bracket 3x squared minus 8x raised to power 4 plus all into bracket 4x squared minus 6x cubed 2x dx. Now from here, expand this bracket, multiplying 2x all through with this bracket, multiply 2x with 4x squared, you have 8x cubed. Multiply 2x with this, what do you have? Negative 12x raised to power 4, right? Plus 8x raised to power 4 minus 3x squared. So let's deal with this expression by grouping. So I'm having 3x squared. This will plus this because they are having the same power. So this becomes what? Negative 20x raised to power 4. Meaning negative 8x raised to power 4 minus 12x raised to power 4 plus what? 8x raised to power 3. And this minus this will give us minus 20. Minus this minus 12 will give us what? Minus 20. So what you are saying is that you have integral 0 to 1 3x squared minus 20x raised to power 4 plus what? 8x cubed. Then differentiate all this with respect to the x. So you are differentiating all this with respect to the x. How do you get this? You got this using this curve. You got this using this first curve. The same way, this idea, that's what you are going to implement to the second curve. This idea, that's what you implement to the what? Second curve. Alright, now let's evaluate this integral. Go back to integration. Let's evaluate this integral. By the time you integrate this, by the time you integrate, applying the general form of integration, add 1 to the power, then what you've added, what was there with what you've added, repeat it. So I have the first one, I'm seeing 3x squared. I'm seeing 3x squared. That becomes what? 3x cubed over 3 negative 20x raised to power 5 over 5, right? Plus 8x raised to power 4 over 4. What's your limit? 1 to 0. Introduce 1 to 0. But before then, let's simplify. 3 cancel out. This cancel, I'm left with 4. This cancel, I'm left with what? 2. Therefore, I have x cubed minus 4x raised to power 5 plus 2x raised to power 4. Introducing your limit. Substitute this limit, meaning 1 raised to the power of 3 minus 4 into bracket 1 raised to the power of 5 plus 2 all into bracket 1 raised to the power of 4. Of course, minus 0. By the time you substitute 0, you have 0. Now, meaning you have 1 minus 4 plus 2. 1 minus 4 plus 2, that's what? Negative 3. Negative 3 plus 2 will give you what? Negative 1. So for this curve, my line, for this curve, the answer for my line integral is what? Negative 1. So the curve that gave me negative 1 is what? Y equals to what? X squared. Now, the same way we did this, the same approach in solving this line integral for this first curve, that's the same approach in solving the line integral for this second curve. So let's solve the line integral for this second curve using this same approach. Alright, now for this second curve, meaning y equals to square root of x, meaning y is equals to square root of x, right? I'm solving. I have integral 0 to 1. I have the integral 0 to 1 all into bracket p dx plus q dy, right? And I'm solving using the curve y equals to square root of x. Nothing is changing, right? My p in this case, or before then, let's differentiate this. Say this is 1. Let's differentiate 1. From here, you can write 1. You can write equation 1 as what? X raised to the power of 1 over 2. Applying your differentiation, you have that y is equals to 1 times 1 over 2, all into brackets, x raised to the power 1 over 2 minus 1, meaning 1 over 2, all into brackets, x raised to the power negative 2. Which is still the same thing as 1 over 2 multiplied by 1 over what? X raised to the power of 1 over 2. That is 1 over 2 times 1 over square root of what? X, dy over dx. Meaning that, therefore, dy over dx is equals to what? 1 over 2 square root of x. Make dy the subject of the formula, meaning cross multiply. You have dy is equals to 1 over 2 square root of x dx. So anywhere I'm saying dy, I'll be substituting this expression. Alright, so this is y, this is y, this is dy. So if this is y, from here, if this is y square will be what? Take square to both sides, meaning you're having this. Then of course, this square root will cancel out. What you are saying is that y squared is equals to x. So take note, y is equals to square root of x, y squared is equals to x, dy is equals to 1 over 2 root x dx. Now, what's my p and q? My p and q are always constant. They are the vector field. So for the vector field, I have 3x squared minus 8y squared, and I have q to be what? 4y minus 6xy. So substitute all the terms into your line integral formula. Substitute all the terms into your line integral formula, meaning integral 0 to 1, all into bracket, what's your p? 3x squared minus 8y squared, positive q, this is your q, right? 4y minus 6, this is the x, plus 4y minus 6, 4y minus 6y dy. Now let's substitute what we've evaluated. I have integral 1 to 0, 3x squared minus 8. I'm saying y squared. For y squared, substitute what? X. Substitute x. So I have minus 8x, all into bracket dx, plus all into bracket 4. I'm saying y. Substitute square root of x, multiply by square root of x minus 6x. I'm saying y again. Multiply what? Square root of x. I'm saying dy, but substitute this, meaning 1 over 2 square root of x dx. From here, simplifying this integral function further, I have that. Let's simplify this. You know, from here, I'm still having, from here, there's nothing to simplify. From here, there's nothing to simplify. From here, there's nothing to simplify, right? But for this, let's simplify this. Let's simplify this. I'm having 4 square root x minus 6x square root x multiplying 1 over 2 square root x. Right? Now, open up expansion, meaning 4 times square root of x divided by 2 times square root of x minus 6x square root of x over 2 square root of x. This cancel out. This cancel out. From here, I have what? 2 minus 3x. 2 minus 3x. So what this means is that I've expanded, I've simplified this to this. So substitute. So I have integral 1 to 0, 3x squared minus 8x dx plus what you've simplified, meaning 2 minus what? 3x dx. Alright, open this, group this together, meaning you have integral 0 to 1, all into bracket 3x squared minus 8x plus 2 minus 3x dx. Okay, from here, grouping this, you have integral 0 to 1, all into bracket 3x squared minus 11x plus 2 dx. By the time you integrate this, we have 3x cubed over 3 minus 11x squared over 2 plus 2x. Then this will cancel out, right? I'm having x cubed minus 11x squared over 2 plus 2x. Now introduce your limit. Your limit is from what? Your limit is from 1 to 0. From 1 to 0. So substitute. By the time we substitute the upper limit, we have 0 cubed minus 11 divided by 2 plus 2 all into bracket 0, right? Minus the second one, 1 cube minus 11 1 square over 2 plus 2 all into bracket 1. Meaning that you have 0 minus all into bracket 1 minus 11 over 2 plus 2. Take LCM. What do you have? 2 go here 1. You have 2 minus 11 plus 4. Meaning 0 minus this. Then from here, this will give you 2 minus 11 is what? Negative 9. Negative 9 plus 4, meaning negative 5. You have negative 5 over 2. That is 0 minus all into bracket. Is this 0? 0. This is it. Minus. This is it, right? Your whole bracket, negative 5 over 2. You have it here. Then minus 9 minus will give you what? 5 over 2. So meaning that for the second curve, by the time you apply line integral to the second curve, you got what? 5 over 2. Now implementing this formula that says that the line integral of the question, of the given question, is equal to this first line integral plus this second line integral. Now what we did for this first line integral, we got negative 1. What we did for this second line integral, which is this, we got what? Positive 5 over 2. Positive 5 over 2. Take LCM. Meaning you have 2, negative 2 plus 5, which is equal to what? 3 over 2. So what this means is that, so from here you got 3 over 2. So what this means is that you've been able to solve that question. You'll be able to solve that question using line integral, and you got 3 over 2. You got 3 over 2. So that same question you are going to solve using double integral. If you get 3 over 2, it means that question it verifies Green's theorem. It verifies it. If you are not getting it, it means it does not verify Green's theorem. So whatever the case might be, state your condition. If it verifies, state it. If it does not verify, state it. Alright, now let's see how you solve this question using double integral. Let's see how you solve this question using double integral. Alright, so far we've implemented line integral right now. Let's see how double integral works. Though we've integrated also, we got our expression, we got double integral. We know our limit, right? 0 to 1 and square root of x and x squared. Then we got 10y dx dy. So let's say this is equation 1. So this is the double integral. Applying double integral to that question, this is what you get, right? So this is we've done this previously. So let's just to see how we got this. You see how the limit works. All right, we've done this previously. Okay, now how do we get this? We said partial derivative of q with partial derivative of x plus partial derivative of p with partial derivative of y multiplied by dA. Meaning the x multiplied by what? Dy. Now solve, since you need these two functions, differentiate. By the time we differentiate the first one with respect to y, meaning the p over dy, you get your answer to be negative 16y. And by the time we differentiate the second function, meaning the q over dx, you get your answer to be what? Negative 6y. So substitute. We then have double integral this 6y, negative 6y minus all into bracket minus 16y dA minus 16y dx dy. This will give you double integral 10y dx dy. But the question is, how do you get a limit? If you look at how to obtain our limit for a closed curve. So we've explained that previously. If this is your first video on this theorem, you can check the previous video. We've explained how we got this limit. We've seen it graphically, and we've seen it graphically, and we've seen it mathematically. So check the previous video. So from here, our lower limit is x squared and our upper limit is what? Y. And our lower limit is x squared and our upper limit is what? Square root of x. So that's how we got this equation 1. So from here, I have integral. Similarly for x, our lower limit is 0 and our upper limit is what? 1. So I have 0 to 1, 0 to 1, integral x squared, square root of x, then substitute this, meaning 10y dx, 10y dx dy. Now from here, integrate with respect to y first. Integrate with respect to y. By the time you integrate with respect to y, you have 10y squared over 2. 2 go here 1, 2 go here 5. Meaning you have what? 5y squared. So you've integrated this with respect to y, you got 5y squared. Substitute the limit of y, meaning x squared and square root of x. You know, this is the integral for y, this is the integral for x. So you are after integrating with respect to y, we substituted the lower and upper limit of what? Y. So what this means is that anywhere I see y, substitute this. Anywhere I see y, substitute this. So you have 5 all into bracket square root of x squared minus 5 all into bracket what? X squared squared. This becomes what? This cancel out. You have 5x minus 5x raised to the power 4. So you've integrated with respect to y and you've substituted your lower and upper limit. You got this. This function, integrate with respect to x and substitute your lower and upper limit. So from there, what do you have? 5x raised to the power 2 over 2 minus 5x raised to the power 5 over 5. Then this cancel out, right? You are left with what? 5x raised to the power 2 over 2 minus x raised to the power 5. Include your limit 1 to 0. By the time you substitute that, you have 5 all into bracket 1 squared over 2 minus 1 raised to the power of 5 minus all into bracket 5 0 square over 2 minus 0 all raised to the power of what? 5. Then this will cancel out. So you have 5 over 2 minus 1 over 1. Take the LCM, meaning 2. So you have 5 minus 2, which is equals to what? 3 over 2. Now, conclude. Make your conclusion. Does this question verify Green's theorem? If yes, why? Does this question verify Green's theorem? Conclude. Yes, it verifies Green's theorem. Does this question verify Green's theorem? If yes, make your conclusion. Make your conclusion, meaning it verifies Green's theorem. How do we know it verifies Green's theorem? When we did for line integral, I got 3 over 2. When I did for double integral, I got what? 3 over 2. So meaning my answers, they are the same. Hence, my questions given verifies Green's theorem. So state it, saying that the given question verifies Green's theorem. It verifies Green's theorem because the line integral is equals to what? Double integral. It verifies Green's theorem because the line integral is equals to what? Double integral. So now, up to this level, we are actually done with that question. That's how it works. So meaning for any related question like this, say you have curve, say you are giving the question to the curve, the function of y is defined twice. Y is this, y is this. And you are not told the intercept of this one. When we say intercept, meaning the value of x, how x ranges, the value of x as it ranges, you are going to calculate it yourself. It is expected from us to know that I'm going to calculate. So just apply what we did previously, meaning equating these two values of x, knowing your range, implement it in your graphical illustration for your curve, meaning the closed curve. By the time you implement it, the purpose of all this is to know your limit. Knowing your limit when it comes to double integral, and knowing your limit when it comes to line integral. For your double integral, you know your limit from your table, meaning the one giving you the greater value of y becomes your upper limit. The one giving you the lesser value becomes your lower limit. Then for your line integral, you determine your limit on how it moves, on how each curve moves. When you plotted it on your graph, on how each curve moves. So from what we did previously, we saw that it moved from 0 to 1, and the second one, it moved from 1 to 0. We move in a counterclockwise direction. So meaning where it is starting from takes your lower limit, where it is ending takes your upper limit. So that's how it works. In some cases, you might see it as, for the first curve, which move in 0 to 1, you might see it as 1 to 0. They are actually saying the same thing. But let's say this is your integral. From what we've done previously, let's say this is your integral. Along OA, you already know that it is moving from 0 to 1, 0 to 1, 0 to 1. But if you are not seeing it there that it is written, it moved from 1 to 0. If you want to represent that integral, it won't be 1 to 0, but it will be what? Integral 1 to 0, which is conveying the same thing that we did. So meaning to just make your work easier, just understand the concept that wherever you are starting, take the lower limit, and wherever you are ending, take the upper limit. So it varies. Not the time you have 1 to 0, 0 to 1, depending on the range of x. If your x ranges from 0 to 5, meaning your limit in this case becomes 0 to 5, and the other one becomes 5 to 0. So it's just for you to understand the concept on how it works.